Hi, my name is Aaron and I'm a rising junior at Limerick High School, and for my main project I initially set out to create a classifier that would determine whether or not a person is smiling. However, over time I have gradually expanded upon this project and added my own modifications, and in the process of doing so, I added a few classifiers that were convolutional neural networks that would solve the multi-class classification problems more complex than the initial binary classification of smile detection. Here's a demonstration of it working, and here you'll see the software guessing my emotion as either happy, sad, angry, surprised, or neutral, and it also correctly identifies me as an Asian male. So how does it actually work? Well, this was implemented using deep learning, and besides being a buzzword, what is deep learning really, and how is it different from all the other methods of machine learning? Well, in most methods of machine learning, the models used are made out of layers with an input layer, several layers dedicated to the extraction of features, and final layers that implement an algorithm in order to determine what the image actually is. In past methods, most parameters were only located in the final layers and that were trained. But in deep learning, in contrast with that shallow learning, there are parameters in the feature extraction layers as well. And in doing so, through the training, the model is able to determine for itself what features are most important in the identification of image recognition. What is a convolutional neural network, and how is it different from any other version of a neural network? In a CNN, there is a convolutional layer, and this layer basically takes in an input image, and through the process of feature extraction by looking at different regions of the image, it is able to highlight what features are most important. And because this method looks at regions of the image, it is able to look for spatial interactions between pixels, and in doing so, it's able to have a more accurate feature extraction process. And despite CNNs being industrial grade methods that are very efficient and very fast, scalable to large data sets, it is really quite easy to implement with the help of libraries like Keras. In the process of creating this project, I definitely learned a lot. The best way to learn about something is almost always to build it for yourself, and machine learning is no different. However, there are some flaws in the initial methods that I used that I used a tutorial, and there were some intrinsic flaws in it that carried over when I tried to implement my own classifiers. So a lot of the struggles that I encountered arose from these intrinsic flaws. For instance, because the tutorial never mentioned a GPU, I ended up training all my models on my computer. However, I definitely regret not using a graphics processing unit, because not only would it have been faster, it would also not have used as much of the memory on my computer, because a GPU has its own allocated memory. Another flaw that I encountered that created a huge struggle was that my model ended up getting overfitted on the training data. In retrospect, I definitely should have stored every single model after each iteration over the training data, because it is better to be safe than sorry. In the future, I hope to take this newfound knowledge that I've gained in machine learning and computer vision and eventually build an app that might utilize similar aspects in addition to semantics analysis in order to solve a task that may benefit students like me, and eventually submit this app in a competition such as the Congressional App Challenge. Thank you for your time.